So, hi everyone. My name is Gilles Fedak, and I'm co-founder and CEO of iExec. And the talk today is going to be about decentralized marketplace and the way we are doing that at iExec. We are building a decentralized marketplace. We are facing several issues, and that's many challenges. And I think that's quite important to understand actually, what are the challenges of building decentralized marketplace on top of Ethereum. And I think that many of the solutions we are having could be applied to other decentralized marketplace. So the agenda today is the following. First, I'm going to briefly introduce decentralized marketplace. I will take the iExec example as an example. At iExec, what we're doing is a marketplace for trading computing resources. We'll see what are the new usages and what are the new business use cases that are allowed by the fact that the marketplace is decentralized. We will also look at the implementation challenges. There are many, and some of our solutions. And finally, I will conclude and give some perspectives. So, decentralized marketplace, what's that? There are a certain number of characteristics. First, the first assumption is that you have transactions that are peer-to-peer without any central authority that take fees eventually. And so all the steps of verification for buyers and suppliers are handled by the blockchain and smart contract, which also automates the verification of the contribution and proceed with payments. So at the moment you have, if you look at in the Ethereum ecosystems, many kind of decentralized marketplace that can be for the exchanges to trade assets, digital assets and cryptocurrencies. It can be generic marketplace such as, for instance, Open Bazaar. It could be also a marketplace for trading non-fungible tokens such as Auctionity, or for trading computing resources such as storage or iExec. So this is really a hot topic, I think, at the moment, in particular with decentralized exchange places. One important feature is that decentralized marketplace are dApps. So you expect the same features that exist for dApps for your decentralized marketplace. Okay, so typically the fact that it's censorship resistant is something really important. Somehow the decentralized marketplace should not prevent someone to enter the marketplace. That's something important. It should be autonomous, transparent, unstoppable, secure, resilient, etc., etc. So there was a great paper I encourage you to read, published at the Communications of ACM, that compare and present the two models, so the decentralized one and the more traditional e-marketplace platforms such as eBay, Uber, Airbnb, and whatever. I just want to focus on two important aspects that that I will explain more in the rest of the talk. The first one is trust. So typically, if you go in a centralized marketplace such as Uber, you basically trust the platform, and then the platform has several mechanisms that evaluate the buyers and the sellers, such that as a consumer, you will be happy with the service provided by the different stakeholders of the marketplace. Of course, in a decentralized way, this is different. You don't have this third party, so there should be some algorithm, there should be some mechanism that automatically and transparently evaluate everyone. And I will show you some example on iExec, the way we are doing that for trading computing resources. And so another important feature is privacy and security. With centralized marketplace, you basically give all your information to Airbnb, let's say, and you don't have any power about what you want to disclose or not to disclose. Thanks to, in the decentralized marketplace, thanks to all those new technology that come, for instance, today we had several talks about identity, zero knowledge proof, etc., you have much more flexibility about the information you want to share and the information you don't want to share. So, for instance, you can have a decentralized marketplace where the terms and conditions are public for using a specific resource, but still the price, for instance, for a given deal is kept private. And same for identity. You can have marketplace that forces you, or you can ask the marketplace to have a clear identity of the one you are interacting with, like KYC, for instance, for the exchanges, or you can have setups that are fully anonymous. And so you have much more flexibility in this. And same from privacy. The thing that is really important to understand is that for decentralized marketplace, the keyword really is trustless. The assumption is that there is no trust between the different stakeholders, and so there must be some mechanism to overcome this limitation. I will give you some examples of that later. So at iExec, we are doing blockchain-based decentralized cloud computing. So this is a marketplace for trading computing resources. So by computing resources, we are talking about servers, so that machines. We are talking about data sets and applications. And we are using Ethereum, to hold all the payments, the resource provisioning, accountability, and so forth. And here, of course, providers interact in a peer-to-peer way, and there's no central authority. So why do we think this is important? First, because there are many, many dApps that are coming, and they need more computing resources than just what the blockchain can provide. They need storage, they need computing power, they need to run any kind of application, and so they need and we think we can provide a dedicated infrastructure for doing that. And in the future, we think that by creating a marketplace for computing resources, we can eventually have a new form of cloud that will be probably cheaper and less and greener, that consumes less energy, that is more efficient, in particular with all the new scenarios that are coming with edge computing, fog computing, 5Gs, etc. Here we need to have computing resources that are closer to the data, etc., etc. So this requires a change in the paradigm, the way we are doing distributed computing infrastructure. So in the marketplace, in the decentralized marketplace, you need to have a token. And this token is important for several reasons. The first one is that this is the token that allows to build incentives in the network. You cannot have trust. I mean, you cannot have a trust, a third party. But on the other hand, what you have, is, thanks to the token, is the ability to build algorithms that manipulate the token, and so that create incentives to behave correctly in the marketplace. And this is a very strong tool, actually. That's something really important. So to understand this is a big picture of how iExec is working. So you have users that are going to use dApps. Those dApps need extra computing power or extra data set. They go on a marketplace. In this marketplace, they can find and provision the computing resources they want at the price that corresponds to their requirements. Once they select the computing resources, the worker pools, for instance, worker pools are a set of machines that are ready to execute tasks. The task is then sent to the worker pools, and all those machines are going to execute the tasks. Once the tasks are executed, there are results. The results now are going to be evaluated through an algorithm that we call proof of contribution, or POCO. And the goal of this algorithm is to say, basically, okay, you ask for the execution of a task with that level of trust. Now the POCO will look at the execution and say, okay, now I decide that this result has been executed with the level of trust you asked for. And if it's okay, the protocol, the POCO will validate the result of the task, and payments will happen. And the results will then be sent back to the user. So when defining a marketplace, you must first think of what's going to be the transaction between the buyer and the seller. So in our case, that's very easy. The transaction is basically the execution of a task. So now you have to decide what's going to be, what a deal is going to be. So the deal, it's going to be, in our case, we have requesters. So requesters are the ones who ask for the execution of a task. So they emit an order. An order, it's actually a structure that say the price, what I want to do, the definition of my task. And then you have three different providers. There is one provider that provides the application. So similarly, the provider emits an order saying, okay, this is my application, this is the price to execute my application, these are the characteristics of my application. For a data set, this is similar, so you have the ability to deploy some data and expose those data and give a price for using the data within a single computation. Okay? And for worker pools, this is very similar also. So you have machines, and worker pools can publish orders saying, okay, I'm okay to execute a task, or I'm okay to execute task at that given price. So a deal is done when all those orders match. Okay? And when a deal is sealed, we register that deal in the blockchain, and once the deal is registered in the blockchain, then we can execute the task. There is the POCO mechanism that validates that the deal has been correctly fulfilled, and then payment happens. So here, one very important thing is that when you define this transaction in your marketplace, that basically going to give you the pricing model. So here, the direct consequence is that the pricing model is what we call pay per task. You pay per task execution. So that's something important, because in traditional cloud computing, you don't pay per task execution. You provision computing resources, you use it for a certain amount of time, and then you pay for the usage, you pay for the time you use the machine. Here you pay for the execution of the task with a guarantee that the task has been executed with the level of trust you ask for. So I talked about proof of contribution. This is something really important. It's a trustless environment. So you may execute a task on a machine you don't know and you don't necessarily trust. So you need a mechanism that will basically say, if I want a very high level of trust for the execution of my task, meaning that basically I want my result to be the correct one, there should be a mechanism that look at that and that provides you a guarantee that it's what you ask for and what you paid for. So the way we are doing that at iExec, so it's a framework first. The level of trust can be different. So you can have a level of trust of 0, meaning that basically send me the result you got and I don't care, I will manage. Or you can have a very high level of trust, and if you execute your application on machine you don't trust, this is this algorithm. So it uses staking and reputation and result certification. So result certification, the idea is that simply you duplicate the execution of a task and then you compare the results. So when comparing the results, we do a majority voting, and if some went, if some workers went against the consensus, then they are punished and we take their stake. So with this mechanism, there is no incentive in behaving incorrectly. Basically, you can always, if you're a worker, you can fake a result, but there is no chance that you earn money at the end. It's like a game show. Very often there is, I think there is a confusion between decentralization and peer-to-peer network. So peer-to-peer network, this is the idea that every node in the network play the same role. So if you remember back in the years, peer-to-peer it was, opposed to client-server, and we are saying that a node is both a client and a server. So decentralization is very different. At iExec, we have many different roles that are identified. And some of the components, some of the services are actually centralized in the, the sense of client-server. So for instance, we have a product that we call the dApp Store. So the dApp Store, everyone in the iExec network can deploy an application. We cannot, it's censorship resistant, so we cannot do anything about that. But we maintain a centralized service that lists the application that we like. So basically people do a simple GitHub request, and if we like the application, we can list this application. And similarly, for instance, we have the worker pool manager. So that's actually at the moment, that's very easy to have your own worker. You just start a simple agent, it will connect to a worker pool manager. So there are centralized services, but anyone can run those services, and that's where decentralization happens. So you have different roles, but no one can prevent you for having your dApp Store or your worker pool manager. And that's something really important. That's something really important because first we expect people to do that. We expect people to build verticals because they have a special knowledge in doing artificial intelligence, much better than us, and they will be able to create some verticals with dataset providers, algorithm providers, they are specialists of TensorFlow, Caffe, OpenCV, whatever, and find the correct computing resources that are efficient, cheap, to execute that. For instance, in the coming weeks, we are going to launch a public worker pool. So what we call public worker pool is a worker pool where machines from the internet, I mean anyone can connect and offer its laptop to execute the computation. So we will do one, but we expect people to create some other public worker pool. Exactly like, you know, mining farms. You have mining farms and you have public mining pools, like dwarf pools. So the way a decentralized marketplace is being designed, I think it's probably closer to what we call market networks. So let me try to explain you. So typically you have buyers and sellers. So in our case, these are the dApps and users of the dApps. The sellers are the different providers. So typically these two layers at the top of the figure, you can find that in a centralized marketplace. What's different is the two other layers that are, you know, what were called core services and core protocols. So core services, these are the ones that we developed at iExec and we manage, but that anyone can replicate. Okay, so anyone is able to create its own broker, etc. What's really important, this is why I call that the market network, is that you can imagine to have many other external services that connect to this network and that fulfill special services, such as, for instance, something that is really important is curators, the fact that you can select the applications, give a recommendation for the application. You can imagine, for instance, OTC, you know, like an exchange, you have what we call OTC. So imagine you are Pixar, you're going to, or Disney, you're going to render your next movie. For that, you need 50,000 CPU hours. Of course, you will not go in the public marketplace. You go on the OTC, and someone will, you know, use his phone call to reserve those machines at a better price. And then the core protocols typically, so at the moment we are developing those core protocols and those core smart contracts, but typically this should be handled by the community. And in the future, we are expecting to have some governance rules so that collectively we decide about how we make the, you know, those smart contracts, how we can modify, for instance, the way we reward people, the way we punish people, and the different mechanisms that are part of the proof of contribution. So this typically should be part of human consensus amongst the community of people using iExec. So typically this is something you cannot do in a centralized marketplace. If you go in, for instance, Uber, drivers in Uber, they don't have the right, or they have nothing to say about how much they will make when they do when they drive someone. The fact that we are doing a decentralized marketplace also create new usages. For instance, the way we trade computing power in iExec is very different than the way it's done traditionally in cloud computing. Usually in cloud computing, you go on a specific cloud provider, let's say Amazon Web Service, and then you have a list of instances. Each instance has its own price, and usually the catalog is quite huge, plus the price varies depending on the region. So that's actually very difficult to take a decision about where to execute if your task is highly demanding. The way we trade computing power in iExec, we trade computing power as a commodity. So think more, think it as like the oil market. You don't care where, when you fuel your car, you don't care if the oil comes from Venezuela, Iran, or Texas. You just fuel your car and go. Here it's the same idea. You don't exactly know which machine is going to execute, but what you are interested in is finding the machine that will execute your task at the best price. So this is the interface for the marketplace, and you see that it really looks like a trading UI. So you have the price to execute a task that varies during time. You have an order book with bid and ask. So people say, I'm ready to execute task at that price. And some others say, okay, I want to be I want my task to be executed at this price. So you have the recent trades, etc., etc. So typically, this is new. It really doesn't exist for traditional cloud computing, and this exists because the marketplace is decentralized. It's because anyone can join and say, okay, I'm ready to do that, to execute those prices. That you can change the paradigm of using the cloud. Another really important thing is privacy and trustless. The fact, because you are going to execute on a remote machine, there could be there is a huge challenge in keeping your data private and confidential. So to solve this issue, we are working using a technology that is called enclaves or trusted execution environment, and especially one provided by Intel, which is called Intel SGX. So what Intel SGX does is that it's basically a feature in your microprocessor that encrypts a part of your memory, and when you execute a process within this enclave, the memory is always encrypted. And so this has very strong consequence. The first one is that it's impossible for someone to tamper the execution. So if you deploy your application, there is no way for someone to generate a fake result, for instance. And the second important feature is that the data will be what we call end-to-end encrypted. So from the input to the output, there is no, the data is never decrypted, even during the execution. So thanks to that, we can also create a new usage, such as, for instance, the data wallet. So at the moment, there are actually marketplaces for data, but they only sell their data. They don't rent the data. So using a decentralized marketplace with, like iExec is doing, plus the technology such as SGX, we can now run the data. So run the data, this is a use case so that you can understand. So here the use case is semantic image segmentation. So the input is one image, and the output is the image with a segmentation. So it says, for instance, I recognize that this is a body, this is a tree, this is a road, a grass, this is used for self-driving cars, etc. This is very useful. So typically, to execute this kind of application, there is one element which is highly difficult to obtain, which is the trained neural network. To train a neural network, this is extremely costly. It consumes a lot of CPU times, and creating this data set is quite difficult, usually. So when someone has trained a neural network, certainly he wants to or she wants to monetize that. So typically with iExec you can do that. So you can have the data set that is going to be monetized, which is the trained neural network, plus an application provided by that provider, plus some GPUs to execute the deep learning application. And so using this, all of the different providers are going to take a reward. And what is interesting is that using, for instance, so if it's, well, SGX does not work with GPUs, but if it's a deep learning framework or machine learning framework that works with CPU, you can even imagine having your trained network being used on some remote machine with the guarantee that the worker machine will not be able to copy this trained neural network. So you can now rent data, and that's something that is really, really important, while keeping full ownership. So when implementing a decentralized marketplace, there are many challenges in terms of implementation, in particular with respect to scalability. So the first version of iExec, we were implementing everything, the order book management, the deals, etc., using, on the Ethereum blockchain. So we now have a new approach for that is called open decentralized brokering, and that addresses the scalability problem of the marketplace. So here the idea is that all the deals are emitted off-chain, and there is a special agent that we call broker, and the broker can match the different deals and record on the blockchain the fact that deals have been sealed. So that's great because it's more efficient, it's less costly for people, and plus it allows for order book management of any kind of complexity. The other issue is that running the proof of contribution protocol on the main chain is also extremely costly, because for every task execution, you basically have to interact with the blockchain, saying, this is the proof of my contribution. These are some hash that describe the result, etc., etc. And so, of course, this is extremely costly. So the idea for that is to create a sidechain, what we call a domain-specific sidechain. So domain-specific means that this is a sidechain that is meant to be used only for iExec, and that we can optimize according to our own requirements. So typically, we want high throughput, low latency, because it's at the end computing. So this morning we had a talk from François Boncillard about that, and I won't elaborate that much on this part. So what you see here is that at the end we end up with a solution which is quite complex. We have the mainnet, we have a sidechain, plus we have things that happen off-chain. So that's first quite difficult to manage. This is what we call a sort of a hybrid blockchain design. So typically the idea is that the mainnet is going to store values and governance, and then there is a sidechain where there's no value, so typically you don't need proof of work or these kind of things, that is optimized for running the decentralized marketplace. And so the question now is in terms of a governance. So for instance, you want to answer a very, very basic question, such as who is able to run a node on the sidechain? Who is allowed, to run a node on the sidechain? How do we want to upgrade the consensus? And so typically, this really raises some governance issue, and you want that to be solved by all the stakeholders of the marketplace. Okay, so as a conclusion, maybe I can take a bet and say that decentralized marketplace can be the next future killer app beside cryptocurrency for public blockchain at least. But there are still a lot of challenges to be addressed to be able to achieve scalability, reasonable cost, overhead, performance, etc. If you like this talk, don't miss the iExec workshop. It's going to be the day after tomorrow And there will be 2 hours of iExec, and here you will have a more technical explanation of all the aspects of iExec, and you can play with the platform, learn how to create your own dApp, how to deploy your application, how to trade computing resources, how to be the next Wolf of Wall Street for the trading CPU times. Okay, thank you.